In this video, we're going to use the very simple scene that Lee has set up to demonstrate what issues we have. Now, Lee, I guess for starters, you could just kick things off by applying our material to the Maya plane real quick.
Yep.
Just for
So,
starters.
yep. So we can get a one-to-one comparison. So we're going
Yeah.
to take our material, which is this M underscore UV test, drag it on. So this is our imported plane, and this is our plane. They don't look the same.
No, there's, let me just kind of, rotate around. It's like, well, there's definitely some differences going on. Still not 100% sure. So, Lee, I'll give you the mouse back. First thing we might want to do is let's just go ahead and get rid of the color influence that we have coming in by
Yeah.
that grass texture.
Yeah, that was the one of the first things I did. Is like, okay, maybe I've got something going on with UVs with the material. Let's see what the underlying stuff looks like.
So then that right there will make you go, whoa. All right.
Yes.
Still, there's it looks like a contrast issue and possibly a direction issue. Can't tell for sure, but then we could start playing with the tiling.
Well, yeah, it's like going, I can simplify it down. So right now it's kind of high noise. Let's drop down our frequencies. So I can go to 1, and I think I can go a little bit
Yeah,
lower.
like point 0.5 maybe.
Yeah, and then I go, well, let's try 0.5 and see what we get. So now we're down to 0.5. So, and even then it's like going, well, I can go a little bit further. So let's go down to 0.25. This is just basically, I'm trying to get to a point where I'm looking for features that could be similar. And I'm looking at this now, it's like, okay, it's not so high detail. Well, I've got shadows coming in. Looks like the light's coming from this direction. So I've got shadows on this side and down, but I don't have shadows on this side. I've got shadows only on this one side over here. So that's like, oh, wow, that's not quite right. And it's like going, and things still don't quite seem, um, something just seems off. Can't really put my finger on it, but other than the lighting, there's something else going on. So this is the point where it's like going, well, how do I solve this problem? Do I start messing around with lighting? Could it be UVs? Is it tangents? What's going on? This is where our test pattern comes in handy now. So even with this is kind of, I can't really mess with it yet. Let's try our test pattern. So if I go over, that was good. I wanted to drag and drop it, not
Yes, I know.
select it. So I will just do it this way. So let's put our test pattern on. So here's our test pattern. Okay, great. Now we got a test pattern. Oh yeah, I scaled it down to 0.25. So let's go over here, set its scaling back up to 1. Well, come on. So 1 and 1.
Ooh, first problem.
Wow, first 2 problems actually. It's like, oh
Well, yeah,
wow.
two.
So something's definitely going on here. This is all warped. It's like going, it's following the contours. Oh, I bet I did something when I was shifting the UVs and I didn't take something into consideration. Funny thing is, that's exactly what the problem is.
So at this point, even though we're doing a setup for demonstration, or actually we're taking advantage of our setup that we put together for demonstrating
Yep.
this issue, we're fixing an actual bug now.
Yep, it's like going, we're going through and solving it, and we're doing this step on my R&D, not the actual one that you guys were on. And I was doing through the steps, and I fixed it on mine. Then we applied the same steps on this one, and we found a bug with it. It's like, oh, yeah, what do you know? There's a bug here. So that particular bug is going to have to deal with the way our UVs are being set up. So if I go in here and I look at my UVs, oh, well, my UVs should be calculated the same way now. So this one's using position X, and hold on, this one's using X. Well, I'm adding vertices. Oh, I forgot to change X to position X. So change that to position X. So I wasn't using the right number for calculating my U's, so everything was shifted by a spacing amount. So we build that out. And if I go back to Unity and we run it, give it a sec to build up, And well, now it's really messed up. So it's like going, right. I missed position X. No, I put that in. What's going on now? Well, this is one that everybody seems to miss. They catch the X and then just change the position X. But everybody on the forum seems to miss that when you use position X, you got to get rid of that time spacing because the X time spacing is already included in the position X code.
That's right.
So you build it again and you go back. Then you hit play. Oh, okay. Now it looks right. Hold on. This one doesn't have a material anymore. So let's go drag that over and compare it. Uh-oh. Something else is still wrong. So this one's coming in, kind of the way we had expected. This one's upside down. All right, well, that's interesting. That means the UVs are messed up. So let's go and fix that. So it looks like it's flipped vertically. So let's go and look at our UVs, and we said that it's flipped vertically. So we'll invert our V's. So we'll basically take whatever V is, subtract it from 1, that will invert them for us.
Okay.
So we go back, and we build it out again. Give it a sec, jump back over. All right, I got to fix that now.
Get tired of doing that during
every single time. Yeah. All right, so let's try this again. All right, now. All right, well, hold on. Still not right. Oh, it looks like we're flipped horizontally too.
Well, hang on. Yeah, okay. Yeah, so flip the other way.
Yeah.
No, you're
it's
good.
Like we flipped it vertically, but it's still not right. So because they're mirror images of each other.
Right.
So it's like going up. It looks like I need to flip horizontally as well.
You're right.
So then we go back over. And yes, it gives me as much trouble in Photoshop when I have to decide if I'm trying to, flip vertically or horizontally. I always pick the wrong one first. So that means we have to invert the U's as well. So now we jump over and run it again.
All right. Now our texture's laid out right, but now we have a problem with our lighting. If we take a look over on the left-hand side, we can see that it looks like the lighting is coming off from the right over to the left at an angle. You can see this by the illumination on this ridge here, and then the shadowing on the inside. Now you can see why Lee did this donut shape here. So we get the shadowing here, and then lighting on the bottom down here, and then shadowing on the other side of it. So again, lighting is traveling in this direction. If we take a look over at the right-hand side, the procedurally generated mesh, it looks like the lighting is coming off from the left, traveling down across over to the right, putting the inside of the donut here in shadow and the outside over here in shadow. So interesting, light coming from one direction on one mesh, opposite direction on the other guy. So we have a problem.
Yeah, and there's only one light in the scene, so it couldn't be possibly that this mesh is being lit by one light and this one by a different one, and I'm using something complicated like layers to mask out which is lighting each light. So what can cause this problem? Well, we've got our bump maps, so they're working, but bump maps are the contributor to our lighting, but our shapes are right because that's why we did this test pattern, so we could verify that we are in fact aligned both vertically and horizontally in the right directions. So it can't be that we're got our UVs reversed because they're aligned right. So the next thing and the only thing left to cause this type of problem is going to be the normals. So to solve that problem, we have to compare the normals that are being generated by us with the normals that are being generated by Unity.
And more specifically, our tangents.
Oh, I said normals. You're right. Sorry.
That's okay.
Tangents.
Our normals are going to be pointing up on both, but since we're still in this demonstration video, we can go ahead and hop over to code.
Yep.
And you have some nice commented out code that we can take advantage of right now that will enable us to see exactly what our normals, tangents, and bitangents are doing.
Right. So that's this segment of code right here.
And we're going to find that our normals look beautiful with both of the meshes that we have in the scene.
So I'm going to take these.
So he's uncommented it on the terrain patch.
Right.
So that means all of our procedurally generated zigzag geometry will come in with the debug lines being drawn for us so that we can visually see what our normals, tangents, and bitangents are doing.
Yep. So if I jump over and look, here we go. And when we designed our system, we set it up that our tangents were going to be calculated in the direction of the z positive, and our bitangents are in the direction of x positive. And they are. They're doing exactly what they're told. And our normals are all pointed straight up because we have a perfectly flat surface that has no height height map information applied to it right now because we set our max height to be 0. Now, to be able to compare this, we need to find some way of doing the same type of layout with our imported mesh. So to do that, we're going to need a script. So we're going to jump over to code again. Go ahead and open up assets. I'm going to look at our script folder. I'm going to right click. I'm going to add a new script. And this is where Chewbacca comes in, but I fired him, and last I heard he got a job as a truck driver. So
What a horrible job. So we'll just call this tangent display. This is a throwaway script, guys.
Yeah, I had to change it.
That sounds good to me.
So it's just something that we can use for debugging. Now, because this is going to be living on a game object and we need to display the debug draw line code, this is going to have to be a mono behavior so we can leverage the update call. So I'm going to make this a mono behavior, and I'm going to implement the update method, and I'm going to copy in the code that I used to draw that stuff. But because this code was originally written to work inside of Terrain Patch, some of this stuff just doesn't work here. So we're going to have to modify it a bit to make it work. We're going to make a variable called mesh, and to get the mesh information, we're going to use getComponent, and we're going to tell the getComponent to grab the mesh filter. Now, I can't just use the mesh filter. I need to get access to the mesh that is contained inside of the mesh filter component. So to do that, I'm going to cast this as a mesh filter, not a mesh render. Oh, come on, work with me, please. So there's a mesh filter. It's been cast. That gives me access to the mesh. So from here, I can use the mesh to calculate everything else. Now, this will be a little bit different because I'm going to use this mesh vertices, because right now I've been taking the vertices, adding position. This was the compensate for the location of our terrain mesh. This particular script isn't going to have positional information, so we need to get rid of that. What it does have, though, is the mesh vertices, so I can replace all the positions with the mesh vertices. In this case, this has to be mesh tangents. No, mesh vertices here, mesh tangents on there. Good. So here, this position goes away. So is this one. And oh, it does go away, but I want the plus sign, and I don't feel like typing a plus sign. So I'll leave the plus sign and replace those positions with mesh vertices. So basically, we're taking every place that had position, we're putting mesh vertices, or the vertex that's returned by the vector 3 that's held inside of or vertices element I as our starting position for all of our draw
We're
lines.
taking each vertex's position.
Did I say vertices again?
I'm just, no. We're taking the position of each vertex. No, I'm just simplifying everything you were saying.
Well, Zach's got to be so self-conscious about saying vertices.
Yeah, I was just trying to help simplify what you're saying. Nothing complex here, just mesh.vertices sub I is just simply returning us a vector 3, which is the location of the given vertex we're currently looking at.
Yeah, and I'm getting rid of all the references to
Yeah,
lowercase mesh filter and all references to position. So that
cool.
gets rid of all this.
Looking pretty happy now.
So if I jump back over into Unity, here's our test plane. If I expand out our scripts folder, here's our tangential display. I should be able to drag that on. We're going to lose prefab. That's fine. This is just testing purposes anyways. So save it out. Well, that's good. I'm hitting F6 to build Unity project. Oh, it's not as bad as hitting F5 to build out a Unity script. Okay, we've got a problem. What are you not happy about? So ignore up here. So get component up. Typo.
There we go.
And yeah, all right. Get over it. All right. No errors. All right. Now we have, our tangents and our bitangents being drawn on both, as well as normals. Normals all look fine. They're all pointed straight up in the air as we expect with a flat plane. Now, our tangents are in blue. Our calculated tangents that we're doing are all pointed along z positive. However, the imported mesh, the tangents that Unity is calculating, are all aligned along negative x. So that is why our lighting information looks different. Now, the way this works is inside of a mesh, which is kind of cool. If we go into our
Down.
meshes,
There you
I
go.
was closing it.
Okay.
So if we go into our mesh, we scroll down to the options for the FBX importer. We have the ability to import normals. We can calculate normals or none. Well, the normals that are coming in from Maya are just fine. Tangents, we have the same type of thing. We can import tangents, we can calculate tangents, or we can just set to none. Now, the export that we did for Maya does not contain any of the tangent information. So even if we were to import it, we'd get none. And I can prove that by hitting import, hit apply. Go ahead and close this out.
Yeah, you do have to stop and restart.
Yep, it does not recalculate on the fly. So if I go back over to scene, you can see that we get no tangents, no bitangents. So if we hit import or none, the result is the same. We just get normals. You'll also see that while we still do have that bump map, the normal map applied, it's not getting any lighting information calculated with it.
Right.
So that's why we need tangents. Now, again, way back in session 6, when we were talking about Unity being able to calculate tangents, this is where it is. We can calculate tangents. I know Unity can do it because it's got a button that says calculate tangents. I have absolutely no idea why they decided that we should not have access to that from scripting. Apparently, it's a dangerous method that could cause the end of the world. Who knows? So they force us to create our own. So if I go ahead and stop and apply the changes so I get the calculated. No, I don't want to import. I want calculated. So now we've got our lighting information back. And we play. Jump over. So we do have our information being calculated for both. So we have no control over the tangent information that is being calculated by Unity, other than the fact that we can tell it not to calculate it at all or import from another application. So that only leaves us with two options. We can either find some way of calculating our tangents on our meshes before we do the import and bring it in to match what we're doing in procedural, or we can go in and readjust the way we're calculating our procedurals to match up with the way that Unity calculates their tangents. That's the method that I recommend that you do, and the way we're going to do it. We're going to adjust our calculations so they match up with the way Unity does it, because it would be a real pain to have to force all of our asset creators to calculate our tangents and make sure that they line up to the way that we design. So let's force our code to comply with the way Unity importer works.
Which is very simple, and that's what we're going to be doing in the next video.
Yep.
So with that, that is going to wrap up this video. Thanks a lot.